Today I am solving a problem that is check if array is sorted and rotated. So firstly, let's get into the problem statement. Given an array nums and we have to return true if the array was originally sorted in non-decreasing order. It means it was either in the increasing form or there were some duplicates present. Then rotated some number of positions which also includes zero, like by zero positions or by non-zero positions. So in this case we have to return true, otherwise we have to return false. And it has also given one condition here, means just like a statement that point that there may be also duplicates present in this part in this original array. So simply that means that non-decreasing order means increasing or some duplicates present. So this is all about let's say if we are having this particular example, so it is simply saying that whatever the array we are given with, we simply have to check if it was originally sorted, and after that it is rotated by some number of positions. That's all about it. In that case we have to return true, otherwise we have to return false. One note is given here that array A is rotated by x positions, and which results in an array B of the same length such that B of I is equal to A of I plus x mod of A dot length for every valid index I. So firstly, let's analyze this particular note properly. So here I have taken this example from this problem itself, first example, where the array size is 5 and having some of the elements 3, 4, 5, 1, 2. And notice already we have read that array A is rotated. Okay, so it is saying that array A is rotated. It means the array A, it is a sorted array, and after that it is rotated by some x positions, which results in an array B which looks something like this. Okay, of the same length, that is of A length, such that whatever the condition is given here, it is saying it is basically mapping this particular indexes from sorted to rotated array, and this is happening for every valid index I. Okay, so to understand it more clearly, let's get here and let me take this particular note down. Okay, so I'm having this condition and it is saying that whatever the number of elements are present in sorted array, those elements will be going in the rotated array in this particular manner. Means whatever the element is present at this A of index this, it will be going at B of this particular index, B of I. So see, this is the sorted array, and here I have taken that which is given this example x equal to 2, it is rotating by x equal to 2 positions. So if I see this particular manner that how it is going to rotate, this is the final rotated array, and this 1 and 2 are present at the last index. So I have found that firstly this 1 is moving at the end, and after that 2 is moving at the end. So this is how this array is looking something like this array B, which is already given as an input to us. Okay, so I can simply, what I can make out of it is that this array is something like left rotated array. So the array is a left rotated array, or I can say that every element, the element this array is shifted two positions left. Okay, this is how it looks like if I take this one, it is firstly going at the end. If we shifted by one position left, and if we shifted by one more position left, it will be moving to this index. Same for this too. If we shifted one position left, it will be moving here at the 0th index, and one more left position, it will be moving at the last index. And this is happening for each and every element present in this particular array. Okay, this is how it is working. Means if this particular array is left rotated array, the array is left rotated, the sorted array, and or we can say that every element present in this array is shifted two positions left, and the final output, which is looking something like this. Now the condition which is given, it is saying same fact which we have just seen here. It means whatever is the whatever the element will be going in the rotated array, this is the final rotated array. Here every index particular index is corresponding to some other index, like this 0 2 3, this 1 2 4. So how it is going to happen, whatever the element is going to come in this zeroth index, how it will be going to come, because we already seen that whatever the element is coming, it is a kind of left rotation or left shift by two positions. Whatever is the element is coming at any particular index, that will be coming from two positions ahead of it. Because if this is the final position, this, then what is the element coming here, the element which is left shifted. And from where it will be shifted, it will be shifted from some position whose index is 2. It means whatever the element is present at index 2, it will be shifted 2 positions back. What we can say is that whatever is this d of 0 is there, the new element which will be coming, it will be coming from 2 positions ahead of the 0 from the sorted array. So it is saying that go in the sorted array, this whatever a array is there, go in that, go at the 0th index and move 2 positions ahead from there. And whatever the element you found there, you take that element and keep it at b equal to 0, sorry, b of 0. So this is simply meaning that in the sorted array, whatever the 0th index is, whatever the second index is, it will be moving 2 positions back at the 0th index, that 2 in the final this particular b array. So where it is going, it is going simply, if we can see that with this particular 2 index a of 2, it is going at b of 0. And if we again see for another one, let's say b of 1, which particular element is coming here, the element, just it is saying that go at index 1 and move 2 positions ahead from there. Whatever the element you found there, that element at a equal to 3 will be moving 2 positions back, that is at b of 1. So this is how it is shown as b of 1. And similarly for every element, this 4 is, this index is going at, this element is going at here, this element, this index, this element is going at here, this element is going at here. So this is how it is working. Now let's see in this table which we have already made, that if we see till this particular point, that a of 4, so this particular index is present, no problem. But if we go till this particular point where a of 5 is there, so if we see that this is going out of bound, in order to avoid this out of bound problem, we will have to wrap around this particular case with length of this particular array a, so that the particular condition of this out of bound is avoid, the problem of out of bound condition is avoid. So in that case we will have to wrap around, so that this 5 mod of 5 comes and it will go to 0th index. So this whatever the element is present here, this 5 index we are going, so it will take this 0th index element and keep it at b of 3. And similarly the 6 mod length of this a, so the 1 will come, so a of 1 element will be going at b of 4. This is how it is going to work. This is the simple a kind of mapping from sorted array to the rotated array for the corresponding number of elements for the positions with respect to the positions. Now now we have understand this particular problem easily, very well, and whatever the this note is there in order to map these elements from one position to another position, from sorted to rotated array. Now let's get into the approach of this solving this particular problem. Now one thing is there, that there are different approaches to solve this problem, but I saw that every approach which I saw, it is simply boiled down to one simple fact, that whatever the example array we are given with, we have to see, we don't know that the particular array is rotated or not rotated. We simply have to determine that if it is originally sorted or not, and if it is sorted, then we have to check if what are the number of breakpoints in the array which we are given with. So it is the simple fact that whatever the array we are given, if it was originally sorted, then after rotation the number of breakpoints will be 0 or 1. Then only we can say that whatever the array was there, it is sorted. Otherwise it cannot be the case, because if the array was sorted and after that it is rotated, that cannot be the case that the number of breakpoints will be greater than 1. That will not be the case. The breakpoints can only be 0 or 1. Only one rotation point be there if also the particular array was sorted by some number of positions instead of 0. So let's try to code this out and understand it point by point. So firstly I am taking this size of this nums in this n, and after taking the size, what I will do is whatever the array I am given with, I will simply traverse to this array. Okay, so I will write a for loop for int I equal to 0, where I will be till which point I will be going. I will go till n minus 2. Why n minus 2? Because if we see in this array example which I am having already, we see in this array, I will check this element with this element. I will put a condition if this particular element is greater than this or not. If this is greater than this or not. If this is greater than this or not. If this is greater than this or not. So that's why I'm going till last second index, that is n minus 2, and I plus plus here. And here I will be putting in condition that if any of the element is greater than the next, let's say this particular element is greater than this. So I am putting one condition that nums of, if nums of I is greater than nums of I plus 1. This is the condition I will be putting, and what I will do in this case, I will increment my variable. And variable I will be taking here, let's say I am taking variable drop count, which is equal to 0 as of now. And if I found that any element is greater than its next element, then I will have one breakpoint. And like in this case, this is greater than this, so I found one breakpoint, drop count here. I will increment this drop count here. Now after completing the entire loop, after traversing for the entire array, what I will do is one more condition I will have to put for the last element, that I will just say in a while, that I will just tell in a while why I'm doing this. I will put a condition for nums of n minus 1, and I will check if it is greater than nums of 0 or not. If that's the case, in that case also I will increment this drop count by 1, and when I will be done with everything, simply return, and I will check a particular expression here, that if my drop count is less than or equal to 1. If this expression goes true, then only I am having whatever the array I am having, it is initially sorted, and after that it is rotated. Otherwise, if it is coming, this expression is coming to false, so I will return simply false. Okay, this is the case. Now let me explain why I am putting this condition here. So the condition I have put here, see in this particular examples. In first example, if we see, then the array is simply this. So I can see that the number of drop counts are only 1. Okay, and also if I as I have already explained here, that whatever the array I'm having, if it is sorted initially and rotated by 2 number of positions, so it is looking something like this. And we have also found that only there is one drop point there from here to here, so it means it was initially sorted and then it is rotated. To understand this particular situation, this particular condition, this example 2 is here, 2 1 3 4. If I try to sort this particular array, then it will look like 1 2 3 4. But in the first, this when I have run this particular for loop, I have found that one drop count was here, and after completing the for loop, I have found in this condition, I have found one drop count from here, that this last index element is greater than 0th index element. Now let's carefully see this particular thing, that this particular element, if I assume that it was initially sorted array, then before rotation with some number of position, let's say before rotation this element was before this 0th index element, then in that case I can clearly see that this element is greater than this element. Then it is obvious that this is not the initially sorted array, because greater element is before, so it is not initially the sorted array. So if I simply see that if it was initial before this 2, so it will be like 4 2 1 3, and the initially this particular element is not increasing, even if you say that the array was in the sorted in descending order. So it is simply saying that it is in non-decreasing order. It means it is either increasing or remaining duplicates. So it is the case of ascending order. So this element, if it was previous this, then simply we can say that the array was not sorted. So we will have to check this particular case also, that the last element is greater than this or not. If that was the case, I will have to increment my drop count to one more. So that's why it is giving as false, and the array was not sorted initially. Okay, and obviously after rotating it will not give us the nums which we are given with here. This is the case. Okay, And it is also the particular example that 1 2 3. In this case, this particular condition which it will increment the drop count to 1. But we can simply see from here that if it is it was originally sorted as 1 2 3, and after it was rotated by 0 positions, it is looking something like this. So in that case also, drop count is 1, so it will simply return true only. One more case can be there, that the drop count will come equal to 0 in the case where the number of this particular array is having duplicate elements. Let's say the elements are like this. It is having the array which is duplicate. So see, this particular array which is given, it will, if we see in the for loop, no any drop count will be increased. If we see in this particular condition, no any drop counts will be no any drop counts will be increased. So the drop counts will remain 0. And also from simple analysis, we can see that if this array is initially sorted 1 1 1, after even it is rotated by 0 positions, or it is rotated by any non-zero number of positions, the array will look simply like this only. So there are no any drop counts we found so far, so the drop counts will be 0. In that case, it will work for this also. It is originally sorted and then rotated after any number of positions, so some number of positions. That's how it is working. Now let me try to submit this particular code. So yes, it is accepted, and let me try to submit it. So after submitting, yes, it is accepted. Now let me tell you the time complexity for this code. So we have simply used one for loop only. So in order to just visit every element once in this array, so yes, the time complexity is simply the go of n only. And also, if we see the space complexity will come out to be 1, because we have not used any extra space. Okay, so that's all about this particular problem. Thank you.